Whoa, this is an absolute blast. So guys, welcome back to more solar trailer stuff. So today I've hooked up this screen, which was already in here, to my Steam Deck. So the thoughts were at some point, maybe I could actually install like a full sim rig in here. That would be pretty cool. With a big widescreen monitor across here or something. And obviously it'd all be running from solar as well. It's got me thinking, because this screen is actually a mains powered screen. So that's its power adapter there. And I'm plugging it into my sockets, which is being powered by the inverter up there. And it's actually quite a waste of energy. Because if you actually look at the power adapter here, it's actually 14 volts, which is basically the same sort of voltage as we're getting from there at 14.5. So to come from our battery and go to the inverter, go up to 230 volts and then back down to 14 volts is just a complete waste of time. It's wasting efficiency and it's wasting power. Now at the moment, we're not actually using anything here, because most of it's coming in from solar, but every little bit of free energy is precious. So how can we avoid wasting it? So how can we run this screen off the low power system in this trailer safely? Right, let's open this up then outside to make it a bit easier. So like most things, the power adapter on this sort of TV or screen uses something like this. It's just a simple DC plug. Right, back in the wall now. So we've got our mains power adapter for the screen here. I've got to admit, when I first started thinking about this video, I didn't realise that this was actually around the same voltage as the trailer's power system anyway. So there's nothing really to stop you from cutting this plug off and just connecting it directly to that battery, but it's probably not going to be a good idea because the voltage range of my battery in the trailer is actually a little bit higher. You know, it could go up to about 16 volts or 17 volts, which is probably going to be too much for that screen. It would probably be fine, but I'm not going to risk it anyway. So to avoid using this mains power supply, we are going to need another one of these plugs so we can kind of, you know, make a way of patching our screen into the trailer system. So yeah, I don't know what that is. There's a myriad of these around, but you might be able to find these kind of on Amazon. What I'm going to do is I'm actually just going to cut this wire. So I'm just going to cut the lead off. I'll be able to reattach it at some point if I need to use it, and I'm actually going to put multi-connectors on here, so I will actually be able to use this adapter again. So it's not going to be permanently sabotaged like most of my stuff. Now the next thing we're going to need is a DC to DC converter. Now, I've been messing around with a lot of RC stuff lately, radio controlled models and drones, all that sort of stuff. You'll know if you've watched the FPV stuff that I'm into that side of it, hence all the drones and bits and pieces around here. I've got hold of one of these chargers. Now this is really interesting because the other day when I got this, I didn't realise that it had this feature, but this can act as a power supply. So what you can do is you can actually plug in any voltage from, what is it, up between 7 and 28 volts input, and then you've got two outputs, and you can actually have you can have two independent outputs at different voltages. So say your TV was running on 18 volts and maybe like you had, you know, something else running on like 15, you could have this configured in your off-grid setup to basically power both devices from this one unit with a single input. And the input range, because this is designed for RC batteries, is huge, 7 to 28 volts. So I mean, that is a really useful tool. So if we take a closer look then, I've just got a 4-cell battery here with a XT60 connector on it, and if we just plug this in here, it'll fire up, and you can see it's a charger by nature, so it's obviously got all the charging functions on here as well. But what you can do, so you can go over here and you can set battery type to power, and that turns it into a power supply. And you can have your output voltage, so we can go up here and we can set this to 14 volts. I'll just keep going past it, hit that, and then max current 2 amps. I don't think that TV is going to draw more than 2 amps, but we'll have a look on the power supply itself and see what it says. But yeah, basically that is how it works. And then all you do is you just hit start. And you see this will climb up to 14 volts, and this will be a proper regulated power supply. It will stay at 14 volts no matter what happens with the input voltage. It will stay at that 14 volts solidly, and you know, if it tries to draw more current, it'll probably just shut down. Actually, I don't actually know what it will do there, but I think it's not going to damage itself. It will shut down before anything happens. So over here, so you could basically just go and set, like, you know, 21. You know, some of these devices have got some weird voltages. So, you know, if you've got something that needs a strange voltage to run on, you've got scope here. You can basically set any voltage you want up to 28 volts, which is going to cover so many things. So if we just put it back to, like, you know, 21, and then again max current 2 amps, and that'll just sit there, and you know, this will climb up to 21 volts, and effectively all you got to do is just basically plug in your loads into those XT60s there, and this will just sit there and do it. Now obviously if the power gets disconnected from here, or something shuts down, then you are going to have to go through here and restart these two power supplies, but you know, that's not a bad thing. Most of the time these things will just sit there running. The advantage with this is if this is sitting there 24/7 running, it's going to be drawing a fraction of the amount that an inverter would, so you know, we're not wasting any energy. Super efficient. So time to sabotage the power supply then. Done that so many times it just doesn't faze me anymore. So next thing we need to do is find out which side is positive and which side is negative. By the looks of it, looks like it's kind of a coaxial sort of format cable, where you've got like a ground sleeve that runs around the outside and the centre is positive. Really should get some wire strippers. So I've stripped back the other side as well, as this is the actual power supply end, because I just want to double check that the white is positive and the other one is obviously negative. It should be. It'd be really weird. It'd be really weird if it wasn't. Get the multimeter. There we go. It's 14.3. It actually says the output is 2.14 amps as well. Bit random, but we'll set it to 2 amps. Right, Mr. Productive, I've just made a cable now with this XT60 connector, which goes in the bottom of here. Well, not that side, this side and there. And then the other end will go in the screen. So let's test it out, see if it works. Right, back in the trailer, take our newly made lead, plug that into the back of the screen. Now, I'm not going to patch this into the trailer at this stage because it's a bit more extra wiring. So I'm just going to run it off this battery. It's effectively the same, doing the same thing, because we've got 15.7 volts there. It's probably higher than what's on the voltage there. Right, there we go. So it's powered up. Look at that, it is drawing 1.5 amps. 1.5 amps from there. So if we put that onto standby, turn that off, basically goes down to, there you go, it is registering something. It's like 0.01 of an amp. And then when we fire it up, it kind of springs into life and pulls, yeah, like 1.5. So let's plug the Steam Deck in and see what it pulls. All right, there we go. So it doesn't seem to be a lot different. Basically, when as soon as the LEDs come on the panel at the back, it just literally pulls like 1.5 amps. So there you go. So that's taking 20 watts. You can see there, 20 watts. Input voltage is 15.49, and output is just the solid regulated 14 volts. So how amazing is that? So yeah, if we just literally put that down into sort of standby mode then, and then that is effectively drawing basically no current from that battery. It's going to be drawing something because of the display and everything like that. That can't be turned off, but it is going to be a lot lower than, say, having your inverter on here just in standby mode. That's going to be pulling like hundreds of milliamps. So we can actually do a comparison. I'll disconnect this and then I'll connect it up to the original power supply, and we'll see what it pulls from the trailer as an idea of wattage. So remember, 20 watts going out. So we're now running off the main socket. I've turned the lights off in here as well, but basically look down there, 38 watts there. So I mean, that's nearly double the power consumption. Okay, this screen's being powered as well, so it's not, you know, completely true, but you know, effectively that's a lot more than 20. It's a lot more than 20 watts, and it's a lot more than 1.5 amps as well. So we've got like 2.2 amps going out there. So it is a lot more efficient doing it that way. Now if we actually pull the plug on the screen, and you'll see here, sorry, it's going to get dark in here, but you'll see here, look, without anything on at all, just the inverter being on is pulling nearly 0.5 amp. So, you know, that will flatten the battery overnight. Let's turn the lights back on. See, my lights are mains powered in here, so I should be doing this with, that's the power supply for the mains for the lights. So I should actually be doing this same principle with the lights in here, because they run off of 24 volts. I don't know if you can see this. They run off 24 volts. So I can literally use that same system, that same charger, to run the lights as well. And then it'd take even less power from the mains. So cool, isn't it? And the inverter is going to be redundant. I mean, for laptop charging and stuff like that, I just need to get some USB-C sockets in here. But effectively, this inverter is going to be redundant. The only thing it's being really used for at the moment is the heating panel, the infrared heating panel. So that is worth having for that reason. But yeah, you can get by. You know, you'd be able to get by without an inverter if you use this sort of principle. Anyway, guys, hope you enjoyed this one. More useful stuff to know, and I'll catch you next time.